Okay, first what you want to do is make sure that you come over to where you can download this program, and you can download the program right here. Okay, that little thing right there will download the program to your computer. Then you can um, print it out if you want. All right, so let's take a look at how we can solve for this thing. We know that anywhere where a radius and a line intersect, that's a tangent point. That's 90 degrees there. It's also, of course, 90 degrees like right there. And of course, that might not be the exact spot, but I mean, you get the idea. It's wherever the radius, the curve of the radius touches the point. Okay, and you would have 90 degrees on all of these as well. Same areas, same idea, same thing. Okay, that also goes true for the ones at the top. So wherever you see this green square, it's going to be the 90-degree point. So what they're doing on this one is they do what they call bisecting the angle. So bisecting it means that, what do you know about a 90 degree? Well, you know that if you have a 90 degrees, the hypotenuse is always 100% of the time directly across from that, 100% of the time. The hypotenuse of an angle is always the longest side. So let's go ahead and create these angles then. Now it's not that straight, but you get the idea. Okay, make that a little bit straighter. And we'll go and do those on the rest of these. So then, now that we've got the angle formed, we want to know, or we want to solve for this distance here and for this distance here. So that would be the distance from this point here to this point here, and this point here to this point here. Obviously, we're going to do the same thing up here at the top. Now, what this means, or what this says, is that we have, or that we know, that we've got 53 degrees as an inclusive angle. So if this is 53 degrees here, this has to be 53 degrees inside here, because it's an opposite and interior angle, right? Opposite, it's opposite of this, and it's interior. This is interior, this is interior. What that means is it couldn't be this one over here. That would not be the 53 degrees. Comes off of this line here, comes down off of that line there. So whatever this angle is going to be the same as this angle here. Okay? Then what you're going to do is bisect that, because you can't work with an inclusive angle. You can only work with one. So we only want to work with this one right angle triangle right here. And of course, we'll work with this one over here. So if we have 53 degrees, 53 divided into 2 equals 26.5. So that's what this angle is right here. This is 26.5 thousandths. I mean 26 degrees, 0.5 minutes. Okay? This is this. All right. So with that, what you want to do is solve for this side right here. You know that's going to be the adjacent side. So you're going to say, okay, so how do I only have one angle. What else do I use? Well, obviously, you're going to use this 375 thousandths radius, which is this distance from here to here. Remember, it's 375 thousandths here, 375 thousandths here. It's also 375 thousandths up here for our next angles. It's 375 thousandths here. It says that the same over here. It is here the same, here the same. Again, it shows you that over here. And it shows you the same over here. So you've got this here and you've got this here. Now you're not going to have to worry about these angles that are tilted at the top for anything as far as solving. You're going to work with just these straight angles. This one, these down here, and this one up here to solve for that, and this one over here as well to solve for your answer. Okay? So what are you looking at? You're looking for this surface right here. This surface is called the adjacent side. And what do you have? Well, you have the opposite side. You have this side right here. You know what this length is. You know that this length from here to here is 375 thousandths. So find the adjacent side by using the 375 thousandths as your opposite side and the 26.5 degrees, decimal degrees. That'll tell you what this distance is here. Then what you're going to do is you're going to take and you're going to subtract this surface here and this surface here from this total distance here. Okay, that gives you a distance then, or an unknown surface that becomes known, or a distance that becomes known right there. Okay, not a very good straight line, but you get the idea again. Put that in there just a little bit straighter. Okay. All right, so you know what this distance is here. Now, what you're going to do to solve for y is take this surface right here, okay, that one there, and what does that take it to? That takes it to the center line of this and to the center line of this. So all you're going to do is add this radius to this outside surface here, because that's what they're looking for. They're looking for the distance to the outside of the ball, and you're going to add this to it. Straight up 375 thousandths, right? Oops, that should be straight. Sorry about that not being crooked. It should be straight. So you're going to, whatever you come up with here, you're going to add 375 thousandths here. You're going to add 375 thousandths here as well. Okay? That'll give you y. Now, how are you going to solve for x? The exact same way. I'm not going to do it for you. I've already done it down here for you. You get the idea, but that's how you're going to get x as well. Okay? I hope that helps, and we'll see you on the next one. Thanks, and have a great day.